I'm Rick Muller. I'm the Senior Vice President and the technical lead of IonQ Federal. So we're setting up a federal division at IonQ to deal with the particular needs that the government customer has. And that also involves working with many of the federal systems integrators, and we've got both represented in the audience today. So many people have talked about how quantum is now today. And I'm going to talk about the federal side of quantum being here today. Quantum's no longer a laboratory curiosity. It's the next frontier of national defense and economic stability, and that means that federal customers have a very relevant concern with the disruption that quantum technologies can bring. Quantum technologies impact how information's acquired, how we process it, and how we transmit it. Because IonQ's capabilities span all of these areas, IonQ can provide an engine to drive federal quantum integration that no other companies can right now. Each of these areas, so we normally talk about them as acquiring is sensing, processing is computing, and transmitting is networking and communications. So each of these areas is important in and of themselves. And there are also intersections in all of these areas that themselves have very exciting capabilities. And I'm going to cover a few high points of these in the few minutes that I have today. Chad gave a great introduction to the Quantum Benchmarking Initiative, and before that, Ariel gave a great introduction to what we mean by benchmarking. And again, just to underscore this, the point is to understand what the utility value is of quantum computation for real-world industrial problems, so the types of things that our customers contend with. Quantum computing was IonQ's first application, and in many ways, it's still a North Star for us. DARPA started the Quantum Benchmarking Initiative a few years ago, and they designed it to demonstrate utility for industrial relevant problems. Most of our quantum competitors are in this field as well, and we think what you're going to see out of us is a real distinguishing of IonQ technologies, capabilities, and performance in the Quantum Benchmarking Initiative compared to the rest of the industry. So when the QBI was designed, it was designed to have 3 phases. The first one is just to show that you have a plausible argument that your system can solve one or more of these industrially relevant problems in a way that pays for itself when you consider the cost of building and running a quantum computer. The next one is a kind of research and development phase where you basically put an R&D plan together that will let you demonstrate that. And then the final phase is stage C, and that's the stage where we co-design and build to kind of demonstrate that we actually have achieved that quantum utility. To date, none of the performers have entered stage C, and IonQ is very close to that transition. We will hopefully be making an announcement sometime in the near future that talks about us moving into stage C. What that means is that we've demonstrated that fault-tolerant operation is feasible on a specified timeline and in a way that has been verified by DARPA, which is the Department of War's most rigorous scientific body. And as many people have pointed out today, fault-tolerant operation puts us in a very different regime. It puts us in a regime where we can make exact solutions to the world's hardest problems, and we think really demonstrate why we've been on this multi-year endeavor to develop quantum applications. So in addition to quantum computing technology, IonQ can now deliver critical sensing technology to the federal customer. And right now I'm going to talk about position, navigation, and timing sensing. So we know a lot of this through GPS, right? Niccolo talked about it earlier. It's the most cost-effective technical development that probably anyone has done since the steam engine. Conventional GPS is something we use every day for both civilian and military applications, but it's vulnerable to jamming and spoofing in contested environments. And in those environments, losing the signal is not an option for critical assets. So IonQ has made significant acquisitions over the last year, and with those acquisitions, IonQ can deliver advanced P&T solutions by integrating the world's most accurate commercial clocks that we got from the Vector Atomics acquisition, with a space-based platform, which we got from the Capella application, and leading optical communication terminals, which we got from a Skyloom application. So these are not random acquisitions that we've made. These are targeted to take critical cutting-edge quantum technologies and make combinations of those technologies that can address incredibly important problem to the federal customer. So Vector Atomics clocks are roughly 1,000 times more accurate than the clocks that are in the GPS system. And that translates directly to 1,000 times more accurate positional sensing. So this isn't just telling you what road you're driving on, it's telling you how many inches you are from the lane line. And that number of inches may not give you a quantum advantage for your driving, but I guarantee there are millions of defense applications that can take that improved resolution and deliver something transformative with that. And only IonQ has the combination of quantum sensing and space applets to develop, validate, and deliver this capability. So this same type of a network, where we're now combining networked ground-based solutions, low Earth orbit satellites, accurate timing, and secure communication, will also provide a foundation for a future internet that is agile, secure, and enables even more novel quantum capabilities. So you've heard a lot about QKD. QKD is an essential element to future-proof communications against things like harvest now, decrypt later attacks. QKD devices can complement and further enhance post-quantum cryptography solutions that you've also heard about. The next step in that evolution is entanglement distribution, where we're looking at kind of end-to-end quantum interaction within a quantum network. And entanglement distribution provides a quantum-enabled internet that allows linking quantum data centers to each other and with distributed sensing networks as well. And these capabilities can be enhanced and further secured using distributed and blind quantum computation to enable secure operations across the quantum internet. This morning, IonQ announced that we had been awarded a contract in DARPA's Heterogeneous Architectures for Quantum program. And this essentially uses IonQ's technology to develop quantum networking devices that can work with different types of quantum computers. And Mihir Bhaskar, who's the final speaker this afternoon, will tell you a little bit more toward the end of his talk. And this is a really critical first step in the vision for that. IonQ is securing the future of the American economy by building the most fundamental tools of the 21st century. And examples of these are unmatched computation, unprecedented sensitivity, and unbreakable security. And with that, I will hand it over to Mihir.